All right, so far we're okay here, right? Y-intercept is 1, 3. What's the domain for this graph? X and all my reals. 4, range? Y is greater than 0. Okay, now I want you to think this through again. All right, and I did this morning, so I'm going to do it again so that you understand. If I said, what is 2 to the power of -1? What's 2 to the power of -1? So I'm working my way right here. There's -1. What's 2 to the -1? What is it? A half. What is 2 to the -2? What is it? It's a quarter. What's 2 to the -3? An eighth. 2 to the -4? A 16th. 2 to the -5? 1/32, right? You see what's happening here? As I go this way, what's happening to my number? It's getting smaller and smaller and smaller, closer and closer to this line, but never going to get there because you can't get a number for x that's going to give us a 0 value, right? So no matter how small. So what that means then is I have a y asymptote at y equaling 0. So there is an asymptote on this graph here, right there. Okay? All right. So I said to you, so is everybody, girls, do you follow this? That weren't here this morning, you follow this so far? Okay. So now, I said to you that there is a change that occurs between the applied, what we did this morning, and what we're going to do. What we're going to do now is the applied does it all by graphing calculator. All of it. You're going to do these transformations without the graphing calculator, the same way you've been doing them from day 1 this year. So what do I see? F of x equals a. I'm going to use a different base here. I'm going to put a base of n, let's say. And you'll see why in a second. B, x minus c plus d. Okay? I don't know what your problem is. You've been doing it from day 1. So what happens? What is a going to do to the graph? Multiply all the y values by a factor of a, right? What is b going to do to the graph? Divide all the x values. You're not going to use that very much for this because it's very hard to tell. We're just sketching. So it's very, very difficult to tell, but you're going to divide your x values, right? What is c going to do to the graph? Come in? Shift it left to right. And what's d do to it? Up or down. Is that any different than what we did for trig, polynomials, for any of the graphs we've done so far? No, same thing. And that's the difference that we have. All right? You are still able to use your graphing calculator, okay? But we still have to be able to file this information and put it on paper. Fair enough? Okay, last thing here. What does that graph look like? Put it on your calculator. What change is made? It's what? The x? Yeah, but what have we done to it? I like what they're going with it, but they haven't got it right yet. What is it? It's a reflection over which axis? It's over the y-axis, right? So it becomes decreasing, like Brian just said. Okay, we established that this morning, right? It's a decreasing value. But without graphing it, I could determine this. Want to know why? Watch here. How do I rewrite this in which that 3 is on top of that fraction? I change it to 3 to the negative x. So now where is my negative located? Directly in front of the x value, which then means it changes all the x values. So all my negative x's, my original, right, was this. All my negative x's become positive, and all my positive x's become negative. So it flips it over. So the value in which b, our base, is between 0 and 1, meaning it's a fraction, it becomes a decreasing graph. It still goes with the same end behavior, still goes through the same y-intercept, still has the same asymptote. All that I have done is change by reflecting it over the y-axis. Fair enough? We okay with that? So then tomorrow, we will go through the translations of these exponential functions, which is exactly what we did up here. We'll just work through that. Okay, so you have today and tomorrow we're going to work on 7.1, 7.2, and probably touch on 7.3. All right? And I think that's it, actually. I don't think there's a 7.4. No, there's not a 7.4 in this section. So it is a shorter section. Those of you not in applied, may be in your best interest to get in tomorrow morning and work on this, because we will be working on it in that class as well. So get your butts out of bed for 9 o'clock, 8:52 actually.
I'm already here from 7 o'clock.
Yeah, you will be. Okay? All right. That's it. You do not work